Dynamic olfactometry is typically used to demonstrate regulatory compliance or confirm modeling. Before you even begin your facility, part of all the approvals that you'll be required to do if odor is a concern for you is an Odour Impact Assessment, and this will be part of your ECA application in Ontario. And what an Odour Impact Assessment will consider is, number one, what types of odor compounds are you emitting and how much of them and when? And also, how are these going to travel out through the world after they come out of your facility? So based on whether, it's coming from putative sources or point sources or a stack of different heights and different output velocities, how is this going to disperse? So this is going to depend on the topography, whether you've got hills that are going to guide the air in certain ways, what kind of wind direction and speed. You don't want to be downwind of a facility, you'd rather be upwind. So the wind is important here. As well as the dispersion characteristics of the actual odor compounds. So just like different molecules will dissolve better or worse in water or non-polar solvents, different odor compounds will disperse at different rates throughout the environment. And then there's all these factors that go into modeling how different compounds will move at different rates. So this model will produce something like what's shown on the right, which shows different odor isopleths around an odor source. And you'll have to demonstrate that you'll be able to meet your odor requirement of 1 odor unit at your POI or whatever it is, as well as that you're not going to be sending odors into sensitive receptors like schools and hospitals. If you complete this modeling and it looks like you actually aren't going to meet your odor requirements based on the technology you've modeled, then you'll just have to beef it up, add more odor collection, add odor treatment systems, maybe do a higher stack, higher output velocity, different things like that. And you can play with those to get to an output that is going to satisfy your regulator and prevent your neighbors from being exposed to odor above 1 odor unit that they're going to detect and potentially complain about and get you fined or shut down for. Now, the odor impact assessment, you need to know the site for, right? Since you're modeling specific receptors and geographic characteristics. So siting is very crucial for integrated solid waste management facilities. Ideally, a site would not be close to the sensitive receptors, would have a topography and a wind direction that would typically be dispersing odors rather than sending them to a certain neighborhood all the time or just sticking around the facility. And along with this, you want to be close enough that you have easy access to all your waste generators and you can reduce your costs and emissions associated with moving your waste around. So it's very hard to do both of those things, but technology, both the process technology and the odor management technology, can help you get there. For an example, what I've shown on screen here is in Toronto. They have 2 AD plants, 2 organics processing facilities, and they're both in pretty populated area. They're both in kind of industrial zones, but as you can see by the map, they're kind of right in the middle of the built up area. And because these facilities are fully enclosed and they have a biofilter to treat the odor and things like that, they're able to operate in that highly populated area effectively and not have odor issues. Whereas other technologies, such as a landfill or a compost, in order to be able to operate, need to be further away from people just because those technologies are less suited to controlling the odor. So by controlling the odor, we can actually have facilities that have better outcomes by being close to people that are producing the waste and reducing our costs to do that, rather than being far away and incurring all those costs just to avoid the odor issues.